Hello everyone, in this part of the lab building series we are going to add another networking concept to play with, spanning tree. Spanning tree is a protocol which is helping preventing loops whenever a redundant connection is added on second layer. When devices on network send broadcast, it is forwarded on all switch ports. Switch which will receive this broadcast will do the same and also forward it on all its ports. If it is redundantly connected like you see, now you should be able to feel the problem, as never-ending looping just unfolded. This is capable to consume more bandwidth and hardware resources into dysfunctional network. Thus, spanning tree blocks the link to prevent the loop. Spanning tree is a big switching topic and I would recommend to take further look on details. Purpose on this video is to implement this concept into our lab to extend playground. Simply start with unplugging existing virtual connections and place more switches on dashboard. In this video we will be configuring single instance MST, which is the latest industry standard version of the spanning tree. It is going to bring also some aesthetic options which I am going to use in future projects. Here pause the video and connect virtual cables to same ports as me, just for easy follow-up. Once it is all connected, just start the switches. We are going to start our journey on switch 1, where I will be configuring VTP first. VTP stands for VLAN Trunking Protocol, but what it really does is replicating VLAN configuration. This will make our rebuilding process a bit faster. I am going to roll with version 2, which is known as Switching Network Destroyer. In real world I would recommend go for a version 3, which have addressed all issues of previous version, however here we are in lab and nothing bad will happen. Next I will move this console a little bit and I am going to configure trunk ports so VLAN information can be transferred across all switches. On the next switch I can skip VTP configuration as VTP settings and VLAN settings will be replicated once trunk link is established. I will simply configure trunk first and then assign end devices to VLANs. After that I am going to create VLAN 12 interface, so this switch will be reachable on VLAN 12. To check if everything is as it should, type in command show VLAN, and as you can see VTP has done its job and VLAN settings are replicated. With command show IP interface brief I will check interface VLAN as well. Interface VLAN 12 is up and running and we can now move to the next switch. On switch 3 I am going to repeat exactly same steps. Interface gigabit 1/0 can be left in defaults, which means it belongs to VLAN 1 or native VLAN. Let's do final checks and we are ready to move to MST configuration. Before we do that, I forgot to establish trunk between switch 2 and 3, so let's quickly fix it. Now let's go back to switch 1 and configure multiple spanning tree. We will start with command spanning tree MST configuration. Here I am going to only set up name for entire spanning tree domain. Typically during MST configuration multiple instances are set. Instance 0 is there for interoperability with other versions of spanning tree. If we set up multiple instances, it would bring option to set up root bridge for one group of VLANs and then set up another switch as root bridge for another group of VLANs. In current scenario, it is not needed as we have one core switch forwarding via one gateway and default instance 0 will capture every VLAN. With following command you are going to tell switch that you are now running MST. With this command I am going to make switch 1 root bridge. To confirm on switch 1 that instance 0 serves for every VLAN, type in do show spanning tree MST configuration. If you are interested to see multiple instances in operation, just create dummy VLAN and configure another instance in MST. Then you can pick for example switch 2 as root bridge for that instance. I am going to attach extended config into the video description. Now let's jump to switch 2 and prepare it to join MST domain. Then tell a switch you are running MST. Configuration on switch 3 will be same as on switch 2. To view detailed spanning tree information on current switch, type in show spanning tree. It will show you who is the root for a particular instance, current switch bridge ID, which is composed from priority and MAC address, then status of the ports. As you can see, interface gigabit 3/2 has been blocked. Assigned row is alternate, so whenever something happens to this link, this block will be released. Leaving most of the spanning tree settings in default, this has been decided because switch tree has highest MAC address in our switch domain, which means on switch 2 we expect that all ports will be in forwarding state and one of them will be root. On switch 1 we are expecting for all ports to be designated as root bridge never block its ports. Let's confirm that with the show spanning tree. On root ID we will have direct information this is a root bridge, and as you can see all ports are designated. One more quick look on switch 2. And as you can see, gigabit 3/0 is root port. To eliminate confusion, I am now configuring host names for all switches. There is one more thing which can be added to spanning tree configuration, and that is port fast command on ports where end devices are connected, which tells spanning tree bring port up immediately without going through the port states. Once command is entered, you should see warning on Cisco switch teaching you about port purpose, so do not attach another switch there.
So just don't do it! Just give up!
And finally, I am going to test connectivity. If everything is properly configured, we should be reaching out. And with that, I am going to say goodbye and see you in next video.